Plastic is arguably one of the most amazing materials ever invented in terms of how useful and robust it is. But the chemistry that gives it those special properties is also its downfall, because plastics are notoriously hard to recycle back into their component chemicals, and that limits what else we can do with them. Now, though, that might be about to change, because scientists in the US have developed a new catalyst that can break apart common plastics and turn them into a host of helpful, high-value chemicals that can be recycled into other useful products. Cambridge University's Taylor Eckert works on ways to deal with plastic waste, and she talked Katie Haylor through what the US team have managed to do.
They've managed to convert polyethylene, which is the most common plastic that we produce today, into a variety of different valuable organic chemicals using just a catalyst and relatively low temperatures. Basically lowers the amount of energy that you need to input in order for a chemical reaction to happen. And because of that lower energy, you can use lower temperatures. In this case, it's platinum on an aluminum oxide scaffold. And the heat, the catalyst, and the polyethylene at 280 degrees Celsius for 24 hours. And at the end of it, they get a collection of different organic chemicals. The cool things about these is they have a lot of applications in industries. So things like surfactants, lubricants, the chilling fluids in your refrigerators, things like that.
What's the breakthrough?
They've basically allowed for two different chemical reactions to happen at once, using the hydrogen contained within the polyethylene to basically help break down those carbon-carbon bonds and split them apart. And also a process where you take these linear chains and you fold them into a six-sided ring. And the combination of these two processes is what allows us to make these really new products that haven't necessarily been produced before.
It's been described as a one-pot solution. What does that mean? What advantages does it have over other ways of doing this, other than temperature?
You literally just combine everything together. You combine your catalyst, you combine your polyethylene. You don't need to add any toxic solvents or any specific types of gases. And then you just heat it up and you're able to produce your products after a day. This is very different from many available industrial methods for chemical recycling, like pyrolysis, where you need a much more specialized reactor because you're often operating at much higher temperatures and pressures that requires a bit more specialized equipment.
How much are we talking about? What kind of scale are they doing this at?
The most that they did was about a gram of polyethylene. You can think about that as about a fifth of a grocery bag that you might pick up at your supermarket.
Oh, wow.
But this is
that's not very much.
All of these things always start at really low scales, but that's okay because it's really just a starting point and there's so much potential going forward from here.
I guess the ultimate question is how much does it cost? Because recycling has to be cost efficient, and if you're going to upcycle some waste plastic, you want a higher value product at the end of it. So is it cost efficient?
So this is a question that is still open to answers. It is more efficient in terms of you don't need to purchase special solvents, you don't need to purchase special equipment. However, the catalyst that they're using does have platinum on it, which is one of the most expensive metals on our planet. And right now they need about 25 grams of platinum for every kilogram of polyethylene that they're breaking down. So that's something that would definitely need to be improved. Also looking at, can you reuse this catalyst many times? That might lower the cost as well. The good thing is that they are converting about 80% of the polyethylene into these chemicals. So there's not really much in terms of byproducts. So for example, other processes have produced different gases which have global warming potential or are toxic. And in this case, you're really not producing much of that. So that's definitely one benefit as well.
Taylor Eckert talking to Katie Haylor, and that discovery that they were discussing by US researcher Fan Zhang has just been published in the journal Science.